Okay, everybody's done but Crew, so we're going to go ahead and get started, right?
No,
Oh,
do them
nice.
all.
Crew, what's the factor of the day? We need two numbers that multiply. This is an easy trinomial, right? Two numbers that multiply to be -7 combined to be -6.
-7 and 1. Positive 1.
Positive 1. Thank you very much for
Crazy.
clarifying. Okay, 5.2. Here's our goal. Here's our objective for the day. Everybody ought to be able to say, I can understand and use, let's see, something to simplify expressions. These are called conjugates. Okay? Now, you may have heard the word conjugate before, maybe not. We're going to talk about conjugates today, several different types of conjugates, and we're going to boil them all down to basically the same type of thing. So in the warm-up, this says to multiply the two of these. So I'm going to multiply here and here. So that's going to be a 4, then a -6i. Then it's the 3i's turn. I multiply the two of those. So this is going to be a +6i. That's going to be a -9i squared. Those middle terms, same variable, same exponent, all that sort of stuff, they're like terms. They're exact opposites. They cancel out. I'm going to say this. I'm hoping everybody can say this for me. What does -I squared count as? Oh, this hurts.
1.
What does -I squared count as?
1.
Okay. What about -9i squared?
9.
Positive 9. Okay, so this counts as a positive 9. Put these together, you get 13. Raise your hand if you got 13. Excellent. The next one's
I was joking.
okay.
No.
The next one's a little different. Listen up. We should recognize some patterns here. We're going to multiply here and here. That's going to be 36. That's going to be plus 30i. Then it's the 5's turn, so this is going to be plus 30i. And then this is going to be plus 25i squared. Okay, let me get this right. What does 25i squared count as?
-25.
-25. So I'm going to cross that off and I'm going to write -25. So this is going to be an 11 plus 60i. Raise your hand if you got that right. Great.
I got a question.
What is your question, Crew?
Why can't I was doing the assignment yesterday and I was like on like this one I did like the square and stuff and it wasn't right because I did it that way and got the right answer. So why is
Let's how about we deal with individual troubled questions like that a little later.
Is there like a different way to do it without like just
Could you
putting
put the square
6
through
plus can you put like the square through it?
Can you square the 6 and square the 5i and just say
Yeah.
you're done with it? No.
No.
Nope.
Is there a way to do it like
No,
that?
there's not. No. It's a common thing. So here's the question. Could I take x plus y and square it? Let me do this in a different color. The question is, can I take any binomial, put a square on the outside, and just square the x and square the y and add them together? No. The answer to that is no, because fundamentally what happens is when you take two terms and multiply it by two terms, you get 4 terms, and you've got to see what happens with those 4 terms. Okay, so you gotta know what happens with these middle terms. Here they happen to cancel out. Here they happen to double up. So you've got to know what you're dealing with. Okay, these are some special cases right here. Mason.
How would you feel if we used J instead of I?
J instead of I?
Yeah.
I wouldn't be okay with that. Why would you want to do that?
Because it's the other way to do it. For engineers.
For engineers? Okay. The only trouble you're going to have with that is every math class you ever take until you get in an engineering class. So if you're okay having trouble in every regular math class, there you go. Okay, can somebody raise their hand and tell us how we do this one? I want to know how to do it, not what the answer is, how to do it. Dane.
So you gotta multiply like the top and the bottom by the square root of 3.
Can you tell me why?
So like the bottom isn't a square root.
Okay. If this is a square root, how many factors do we need in order to pull them out? In total, we need, Samara? We need 2. How many do we already have? We have 1, so I need another one. So I'm going to put another factor of radical 3 down there. So this is going to give me 7 radical 3 over square root of 3 times square root of 3 is 3. Can I cancel the 3 with the radical 3? No. Okay, so we're done. This is the answer right here. Let's take a look at the next one. Okay, do not say anything out loud. Give everybody a chance to think their way through this. I came around, I saw several people got this figured out. This is slightly different. This is a cube root. When you're looking for cube roots, we need groups of 3. Right now I have 1. I have a 2. Luke.
So you multiply it by radical 4?
Not quite a radical 4. We do need a 4 here, but we need to match the root. We need a cube root. So we'd multiply the top and bottom by the cube root of 4. I'm multiplying by an ugly looking 1. It changes the way things look, but it doesn't change the fundamental value. So this is going to be the cube root of 4 over, this would be the cube root of 8 now, or if I wanted to write it out, the 2 that was already there plus the 2 more 2's that I put in by putting a 4. So there's a 2 here.
What?
Crew, can I cancel the 4 with the 2?
No,
No, why not?
because it's not like a radical and that's a radical.
Yeah, we kind of get what he's saying, don't we? Okay. That is not really a 4. It's the cube root of 4. If you put it in your calculator, you're going to get a really ugly decimal for it.
Let's
So it's
see
not a
it.
4. It's the cube root of 4. Okay.
What do you think the ugly decimal is?
I'm going to guess 1.3.
How would you guess?
Maybe a little bigger.
Because he's a pro. Wait, what?
Never mind.
Wait, are you
Okay.
gonna cube?
Let's move on. Okay. Simplifying expressions can be a little bit tricky, especially when we're dividing, as we saw on those last couple of examples right there. We can make division of complex numbers a little bit easier by using something called a conjugate pair. So here's what a conjugate pair is. This is what the I can statement is all about. Complex conjugate pairs have the same real part, but the opposite, so write opposite right here, the opposite imaginary part. So if I've got A plus BI, the opposite imaginary part, we'd still have the positive A, the real part stays the same, but then we have the opposite imaginary part. So A minus BI and A plus BI, those are called complex conjugates. Okay? And you'll notice that we actually had some complex conjugates in number 1 up above. So if you take a look at warm-up number 1, those are conjugates of each other. 2 plus 3i and 2 minus 3i are conjugates, and you'll notice that the answer turned out pretty nicely. So what we're going to do to start off with is we're just going to figure out what the conjugate is of each one of these, and we're going to multiply them together and show that we've got this really cool pattern. So the first thing we're going to do is, this technically is 0 plus 5i. So that means the conjugate of that would just be negative 5i. So there is the conjugate. Now I'm going to multiply those together. So I'm going to take 5i and I'm going to multiply it by negative 5i. I get negative 25i squared. And if I count that the right way, what does negative 25i squared count as? Positive 25. So this is the conjugate part. This is what I get when I multiply the two conjugates together. So for this one right here, this is 6 plus 3i. So its conjugate is going to be 6 minus 3i.
What?
That part's
Jack,
really
how do you
easy.
know that?
Thank you. So we're going to take 6 plus 3i and we're going to multiply it by 6 minus 3i and we're going to see what happens. And this is why we want to be really careful when we're multiplying binomials. 6 times 6 is 36. 6 times negative 3i is negative 18i. 3i times 6 is positive 18i. And 3i times negative 3i is negative 9i squared. Those middle ones cancel out. So I get a 36, and what does negative I squared, negative 9i squared count as? Positive 9. So I put those together, I end up with 45. So there are the conjugates up at the top, and here's what happens when we multiply the conjugates together. We get a nice number. So I'm going to do the same thing with this one, but I'm going to zoom in so we can see a little bit better. I don't change the real part, I only change the imaginary part. So this is going to be negative 2 plus 6i. That is the conjugate. I'm going to multiply these together. So I'm going to do negative 2 minus 6i, and I'm going to multiply it by negative 2 plus 6i. And all I have to do is be careful when I'm multiplying, and I'm going to be just fine. So a negative 2 times a negative 2, 4. A negative 2 times a positive 6i, negative 12i. A negative 6i times a negative 2, positive 12i. And a negative 6i times a 6i is going to be negative 36i squared. Those middle terms go away. So I get a 4, and this is a negative 36i squared, which counts as
40. Oh, that's
36. Add them together, and then we get a 40. Okay. Luke, question.
So I think I see a pattern here.
There is a pattern. We're going to get to that in just a second, see if it matches up with what you say. Mason.
This is just difference of squares.
Oh, hold on just a second. Okay, hold on. Okay, take a look at this one. This is not an imaginary number. This is not a complex number. This is just 4 plus radical 5. Let's see if we can do the same thing. So the conjugate of that, if we tried this out, and if you were paying attention, these two guys just spilled some beans here. Maybe they read ahead a little bit. If you do 4 minus radical 5, let's see if the same idea works with this. So this is going to be 16 minus 4 radical 5 plus 4 radical 5. And then this is going to be a minus radical 5 radical 5. Radical 5 times radical 5 would be radical 25. So this is just a minus 5. What happens to those middle terms? They cancel each other out. So I've got a 16 minus 5. So I end up with an 11. Now, do not say anything out loud. If you were listening to Mason, he just kind of said this. Is this what you were looking for? What was the pattern you noticed, Luke?
So the pattern is that you just so with this one, so with A you just square it, with B you square it and add it, and then with D you square it and subtract it because there's no I.
Okay, yeah, you could definitely think of it that way because whenever we have that minus there, yeah, they're going to be added together. Okay, so Mason, what did you just say?
It's just a difference of squares.
Would you put a star by this? When we talk about conjugate pair, if I say I've got a conjugate pair, it's basically a fancy way of saying, hey, I've got a difference of squares. And the cool thing about I squared is it turns into a nice real number like negative 1. And the cool thing about squaring something like radical 5 is it just turns into a 5. It gets rid of the radical part. So in both cases, that square part allows us to get rid of the radical, whether it's a radical negative 1 or a radical 5 or whatever. Okay, so it's basically just a difference of squares. So remember, I is the square root of negative 1. So if you have an I in the denominator of a fraction, you've really got a radical in the denominator. And if there's a radical in the denominator, we don't like radicals in the denominator, so we do what we call rationalize the denominator. So we're going to rationalize the denominator. So take a look at this one right here. We'll start off with some easy ones. And it does say write the answer in standard complex form. So write it in form A plus BI. So I'm going to zoom in on this one right here. And here's the only thing I need. The only problem is there's a square root of negative 1 down here. We write that as an I. So if I put another I down here and an I up there, I'm multiplying by a funny looking 1. This is going to give me a 3i on the top. It's going to give me a 5i squared on the bottom, which I don't need to ask everybody because I know you're all good at this by now. That counts as a negative 5. So we probably ought to write this as negative 3/5 I, so we can see the imaginary component right here. You can write it like this. This is how we would normally write it, but the instructions do say write it in standard form. So this would be 0 minus 3/5 I. This is how we'd write the answer. So the real part is 0. The imaginary part is negative 3/5.
Don't want the I in the numerator.
Usually not. We usually slide it out to the side, just like when we're doing y equals mx plus b or something like that. We normally slide the slope out front also. Okay. This one's written a little bit funny to start with. You can either simplify at the beginning or at the end. I need an I here and here. That's going to give me a 6i on the top, and on the bottom it's going to be a negative 4i squared, which is going to count as a 4, which is going to give me 3i over 2, which if I want to write it in standard form, 0 plus 3/2 I. Okay. Now, we would normally just write it as 3/2 I, But the instructions do say write it in standard form for complex numbers, so we want to have the real part and the imaginary part. That's kind of a pain in the butt on the first two. It's less of a pain in the butt on this one right here. So let's take a look at this. I'm going to multiply by I here. Got to have the parentheses. It wouldn't work if you just multiplied the last part there. You've got to multiply the entire numerator by the I. So that's going to be a negative 3i plus 10i squared over negative 6i squared. So this is going to be, let's see, negative 3i minus 10 over 6, because negative 6i squared would count as a positive 6. I'm going to flip-flop the two of these, so this is a negative 10 minus 3i, and I'm going to divide both of them by 6. So if I keep going with this, I get a negative 5/3 minus 1/2 I, and there's the real part and there's the imaginary part. So not hard, maybe just kind of a pain in the butt. Okay, everybody good with that?
Yeah.
Okay, that's some arithmetic where we're rationalizing the denominator when it's just got an I in the denominator. These other problems are going to be slightly different. Each one of these problems, you'll notice that the denominator has a real part and an imaginary part. So we're going to multiply by, gosh, if I could just square each one of those, especially the I, I'd get rid of it. So we're going to multiply by a difference of squares. So the factoring for a difference of squares would be 3 minus I and 3 plus I. So I'm going to multiply the top by 3 plus I also. It just so happens that has a fancy name. Crew, what's the fancy name for that? Multiplying by a silly one. That's called rationalizing the denominator. And these two things have names. What are the names for these two things, since they have opposite imaginary parts? Dane?
Conjugates.
Conjure something. Okay. Thank you for that wonderful pronunciation. They're called conjugates. Okay. They're called conjugates. So we multiply by the conjugate, or as we've said before, just multiply by a factoring of difference of squares. This is going to give me 30 plus 10i on the top. And it's going to give me 9 plus 1 on the bottom. Watch. How'd I get it? Square the first one. Square the last one. What does negative I squared count as? Plus 1. And won't those middle ones cancel each other out?
Yes, they will.
You have them skip 6 and 7 on the practice test.
Yes.
Should I have Marcia's class do the same thing?
Yeah, it would. Yeah. Yep. Okay. If you want to write out those middle terms are always going to cancel, aren't they? Isn't that what happens with the difference of squares? Okay, so this is 30 plus 10i over 10. So this is going to end up being 30 divided by 10.
3.
Plus 10i over 10. So this is going to be 3 plus i. And we've written it in standard form.
1. Great job.
Any questions?
Dan, I bet you couldn't do that. I probably couldn't.
Oh, man.
Lizzie?
Is it a coincidence that the answer that we got is the same as
It is a coincidence on this one. Yeah, we'll see it on the next one. Great question. So she just noticed that it turns out to be the same as the top. That's because this is a 10 and the bottom happened to turn out to be a 10. Normally it doesn't work that way. So let's do this one. You can either call this a conjugate, or you can say I'm going to multiply by a factor of a difference of squares. This is going to be negative 2 plus 6i and negative 2 plus 6i.
Yes.
The top's going to turn out to be negative 10i and plus 30i squared,
Oh, that is.
because there's an I on the top already.
It's just negative 3.
Hold on.
All right. Okay, the bottom is going to be the first one squared.
4.
Then the middle ones are going to cancel out. This is going to be negative 36i squared, which somebody pointed out because that middle one's going to be, or that it's going to be a negative, then an I squared. This is going to count as a plus 36. So this is going to be a plus 40. Still some simplifying to do.
Mhm.
This is going to count as a negative 30. So this is going to be a negative 30 minus 10I all over 40. And then we're going to break it into two pieces. So negative 30 over 40 minus 10 over 40 with an I there. And this should take care of Lizzie's question was that a coincidence on the last one? Definitely a coincidence on the last one, because this works out to be negative 3/4 minus 1/4 I. And there's our answer. Okay. Any questions? Okay. Would you do the last one, please?
Yes. Mhm. Okay. So this one. We're gonna go like that. That's like. So 4.
Lots of fraction stuff floating around there. Good. I see some comparing. You're welcome to compare.
Oh, I forgot the square correctly. So 100. Caleb, what do you get?
Holy cow, are you kidding?
Huh?
Okay, let's take a look.
It's gonna be like a two-step problem.
Does anybody think they got the right answer?
Yes, I'm not done yet.
Maybe. Just maybe.
What
I'm
do you
not
think?
done yet, but
1/3 plus 11/24 I.
1/3 plus 11/24 I. D.
That's right. Wait, I'm not. That's also what I got.
Luke.
I got 16 minus 11I over 26.
I
It,
know
it
I'm
did.
right.
It did say write it in standard complex form, right?
Yeah.
Okay. Take a look.
I for sure got it right.
What?
Yeah.
Wait, what?
Okay, hold on. Take a look. Let's take a look at the bottom.
You got that wrong.
Okay, if I multiply these together, this is going to be a difference of squares, right? So it's going to be a 4 minus 100I squared. That's going to count as a plus 100. Is everybody okay with that?
Yeah.
So 104 on the bottom. Is that fine?
Yeah.
Okay, when I multiply the top together, I get a negative 6.
Yeah.
When I multiply there, I get a plus 30I.
You typed in.
Yeah.
You got
Okay,
Yeah.
multiply the 7, so that's going to be a negative 14I, and then multiply here, that's going to be a plus 70I squared. Okay, did I make a mistake there?
Fine.
Yes. So. Yeah.
We okay there?
No.
No, he's
I
right.
didn't-
No,
I didn't
not
say-
Okay,
Silly.
hold on, keep going. This counts as a negative 70, correct?
Yes.
So these two together make a negative 76. These two together make a plus 69.
Yeah.
On the bottom is a 104. We right about that?
Yeah.
Then I come here, I'm going to break it into two pieces. I'm going to do negative 76 over 104, and I'm going to do 16 over 104 with an I on the end. Everybody okay to there?
Yes.
Okay, what's 76 over 104?
1996 over 26.
Oh, 19 over
Negative
26.
19.
Oh, and that's a 26. There we go.
You
Does
know,
that
you-
look
you-
better?
You would like you saw
And then the other one, I can go even further with it. So this is going to be 213.
You thought it was like 114. You felt like 104 was like 114. So you
Okay.
divided it by like.
I forgot to multiply by the
four goes in there. I was thinking
conjugates.
25. Okay, listen up. Okay, is that right?
Yeah.
How many got it? Oh, very nice. Good job. Good job. Okay, come down here and take a look at this, and then I think you're going to be happy with the assignment. Does this same thing work with real numbers?
Yeah.
Yeah.
So we saw this a little bit earlier. I grabbed one and I said, well, let's take this and let's multiply by its conjugate or multiply by a factoring of a difference of squares, 4 minus radical 5. And look what happens. So the top is going to be a 12 minus 3 radical 5. The bottom, remember, those middle terms are going to cancel each other out. This is going to be a 16. We did this earlier, right? Plus 4 radical 5 minus 4 radical 5, and then minus radical 25. So this is minus 5. So this is going to be an 11. Does that make it look nice? And the cool thing is you can actually just leave it like that. There's no standard form for writing that. Could you break that into two pieces? Absolutely, you could if you wanted to, but you don't have to. The two pieces would be 12 over 11 minus 3 elevenths radical 5. You could have the radical 5 on the top, on the side, wherever you want it. You just can't put it on the bottom. I like the first one better. Is that all right?
Yes.
So if we take a look at the next one, the conjugate, in other words, the factoring for a difference of squares is 1 minus radical 2. So we're going to multiply the top and bottom by 1 minus radical 2.
Wait.
Oh, sorry, plus.
I was like
Plus.
waiting for someone to say something.
There we go. Okay. Now go ahead and finish that.
Oh, I'll want to know.
This is.
Oh my goodness. Like math. Math.
What did I do?
Yeah, that's what I got. So that's what it is. I guess.
Did you do that?
You
Yeah.
did
I didn't hear it. Okay, listen up. Kind of cool how the bottom turns out. What does the bottom turn out to be? A -1, which means when you get the answer for the top, which, correct me if I'm wrong, is, whoops, this should be a 3, is that big ugly mess, which means all you need to do is multiply everything by a -1. So that's going to change this to a plus, a minus, and a minus. And did you get that answer?
Yeah.
Mm-hmm.
Raise your hand if you got that right. Okay.
Mine wasn't in order.
While I'm handing out the assignment, would you do that last one?
No.
While I'm handing out the assignment, do the last one.
Yes, I will. Gotta go like.
Oh, which is just.
Relatively quietly, thanks.
Oh, my bad.
don't like that. I don't miss it before.
No.
What? What?
I'm gonna see you in Orlando.
I'll see you in
Yeah.
December.
Oh yeah.
Florida.
Like what?
Divide it all by
What?
6. So I can.
It's,
That would
it's four. It's 4 minus 10. It's just 4 minus 10.
Wait, is 4 minus 10 negatives?